Thank you everybody for joining. Today we are going to talk about FFFL and how the GTL-1000 can help increase the values on it. Basically what we're trying to do is yield higher numbers, meaning flatter floors and leveler floors. My name is Andy Huntley. I am the Scanning Technology Sales Manager for Topcon Positioning. I've been doing some kind of surveying, construction layout, scanning, positioning for over 10 years. The last company I worked for was one of they're in the top 10 of the concrete contractors for North America, and I oversaw all of the scanning technology plus research and development on newer technology. While there, I became certified in both FF and FL through the Face Company, which is also known as the dipstick, and also certified in F number theory, which is by Allen Face Company, which has the D meter and the F meter. So with all this technology stuff, I've pretty much seen them all, played with almost everything there has to be. So here's our agenda, and the way I broke the agenda out is the way we need to approach any job site and how to get concrete contractors to see how this technology works. The very first thing is the edge forms. We need to check the edge forms for levelness, make sure they're perfect. Next, we're talking about placing concrete. Then we'll do what's called, I call it a rough scan, and I'll explain it in a little bit. Then we'll jump into smoothing the surface, which those are the machines that go across the surface to help smoothen it out. And then we'll do a fine scan. And then as soon as the slab is ready, then we'll turn around and scan it one last time to get our final deliverable, which is going to be that FFFL. So let's jump in. First thing, let's check the edge forms. So when we're checking the edge forms, what we want to see is the edge forms are perfectly level. The reason this is the most important thing is because this is your FL value. This is it's actually called face levelness. You might hear it in the industry as floor levelness. If my edge forms they're not perfectly level, you'll see it going up and down, up and down. Well, that's going to affect my levelness, and can also affects my FL or my FF values, the face flatness. The best way to check this slab or the actual edge form is to take a as-built shot every 12 to 18 inches all the way around. And by doing this, we're seeing, do we need to raise the edge form up or lower it down? And so you're just moving all the way around your pour area. So in the data collector, what are we looking for? Well, if you go into as-built and you change it from normal to plan view, you'll see right here with our custom configuration boxes that we can have a height. Well, it's elevation, and this is the height. The next thing is over here, you also see distance between the last point. So we can make sure we're maintaining a good 12 to 18 inches all the way around. And then we can also start checking our heights really quickly. And if we notice that there is an issue, we just take a can of like orange spray paint or something, and we mark that area. And then we have the carpenters come in and they'll readjust it as needed. I've been on several job sites where we check the edge forms, and when we check the edge form all the way around and we fix any issues that have happened, we have yield FL values in the upper, I would say 50s to 75 points, and that is pretty level. Placing concrete. You notice I got dollar signs. This action is where concrete companies make money. Concrete guys only if they're placing concrete. So it doesn't matter how much work they do before they place the concrete, and it doesn't matter how much work they do after. The only time they make money is when concrete is actually being placed on the ground. Now, the GTL can help this with like this machine right here that you see, the Laser Screed. We can run what's called LPS. And what LPS is it's where the robotic total station controls how far down that head that's pulling the concrete back is sitting. On a flat slab, you kind of have two choices. You can run LPS if you want, or you can run a 2D mode, which is with the laser system, and you have a rotating laser that's controlling the elevation across, kind of like just right here. So if you want to yield higher FFFL values, you're going to want one of these machines, a Laser Screed. So how does the GTL work when we're using it as an LPS? What you'll see is I have a robot, the GTL, sitting up on a tripod at the far end of the slab. And what it's going to do is it's going to communicate to the prism, and it's going to give the prism its X, Y, and Z location. Well, the big thing we worry about is the Z value. And so as it's pulling it, it's giving it its location over and over again. And the machine can adjust the head to make sure it's perfectly level. All right, so we placed the concrete down on the ground, and the Laser Screed has come through. It's raked it back. It's somewhat level because the screed head can be any size between 8 to 12 feet in length. So it's pulling it back. At this point, we want to conduct our first round of scans. The reason we want to do the first round of scans is this is our starting point. This is where when our finishing crews come in, they get an idea of what they're about to tackle. And when you do this, to do one scan and actually start showing where all the highs and lows are should take you about 15 minutes. So you're not talking a lot of time at all. And that's from starting a standard scan with images all the way to processing it in Rithm and exporting it back into magnet field layout. So having the GTL for this part of the project can right away start catching issues. The guys that are, like you see the crew in the background of the photo, they're placing the concrete and they're using 2x4s to rake it down. They didn't have a Laser Screed. So this step right here is very crucial for them. Well, here's the workflow we would do for this. One, they've got the concrete placed and they did a rough raking on it. We'll go in and scan. It takes about 4 minutes to do the scan. As soon as the scan is done, I will pull the SD card out of the scanner, put it into our magnet collage software, clean it up a little bit. And when I say clean it, I'm getting rid of the excess perimeter around because I only want to deal with the point cloud that pertains to the slab. I'll turn around and export it right into Navisworks. From Navisworks, I'll import the data right into Rithm and create the contour map. Exactly what you see here. This slab here is kind of a unique one. It is a elevated parking garage. So it's a cast in place podium deck and it's ramped up. So as soon as we have the contour maps, it looks good. I try to keep them at 1/8 accuracy, so you will have a ton of contours, but you get a clear idea of what's going on here. I'll turn around and export it as a DXF. As soon as it's on a DXF and I have it on like a thumb drive, I'll plug that thumb drive into my FC6000 or 5000, and I will load that, the same line work I just had in Rithm, put it into the magnet field layout software and start checking the lines. And if I noticed if I had like a bird bath or a high point, I would select that line and then start staking it. And the way I would stake it, because most concrete companies pour at night or in the early mornings because they get better service out of the batch plants that time, you can have the laser pointer and turn it on and let the GT part of the GTL start walking a finisher around. So I always recommend, if you can use the laser pointer, definitely do it, because the guys, I don't know if you've seen them place concrete, but they walk on skis looking things. They're metal trays, and they kind of shuffle their feet across the slab. So they don't really have a lot of room to walk around or carry a bunch of stuff. And doing it this way with the laser pointer, they can easily see the laser pointer, and they can take one of their trowels and put like an X right there, so they know that, hey, this is a high spot. Or they can do like a circle and show that this is a low spot. And doing it that way, you're allowing the GTL now to communicate to the guys in the field to give them a game plan to start their work. So we've now gone through, we've scanned the slab, we've checked everything to make sure it's as close to level as possible, and we want the levelness. The flatness is a little different, but we're more concerned at this point about the levelness, and I'll show you why here. The flatness is going to be changed by these guys. These motor trowels can increase your FF value, or it can hurt your FF value. Typically, you'll see these machines when the concrete is starting to get a little hard enough that, one, it can support the weight of the machine, but it's still wet enough that they can start smoothing out the surface. You'll see anywhere from 1 to 6 of these machines on the slab, depending on how big the slab is. And then you'll also potentially see a guy that's walking behind it and you going that route. And he's got just like one head on there. These guys will go over the slab many times, and I'll show you a video here in a second of 3 guys just going back and forth, kind of like mowing the grass on your front yard. They're just going back and forth, making sure they cover this whole entire slab multiple times. The purpose of these machines, though, are they use them to, one, smooth the top surface off, kind of give it a polish in a way. But it's also to push the concrete if it's a high area, or pull it into low areas. So these guys are what's going to help or hurt your entire concrete slab. They are the ones that are going to control your FF values. Because, like I used the example just a minute ago, the mowing the yard, think about your mower. If you have one side tilted up too high, the right side's tilted up too high and the left side's low, you're not cutting an even cut all the way across. You're going to have like this kind of sawtooth looking front yard. Well, that sawtooth looking front yard or concept on a concrete slab can hurt the FF values, because the FF value is graded by every foot. So you want to make sure you're completely flat, you're overlapping all the time. And that's why they go over the slabs many times. So like an example here, you see The guy in the green, he's more working on the finished area. The two in the red, they're working in an area that's just been placed, so they're kind of doing a rough smoothing or rough grading on it. The one in the green's doing that fine grading. So guys are out there, they're running the motor trellis across, and now they think they've got it. They're not 100% sure, but they think they've got it. So we'll go in and do a fine scan. And we're going to repeat the exact same type of scan that we did, but we're going to focus in areas a lot more. Because these guys, they work in sections, like you see this video here. We want to scan it and get them results, but we want to make sure the results we're getting them will help fine tooth everything in, so that when we go to do the FFFL scans, everything works. I will say it is best to do this scans when the concrete still have, if you're working with regular colored concrete, not the specialty color mixes. If you ever watch the concrete, it's best to do it when there's still a little bit of a green tint. That means the concrete is still wet enough that if they need to work with it, they can. But as soon as it gets this like water looking effect to it, it's now no longer wet enough. So, and once you get to this point here, you got to be quick, because your window of time to work is like minutes. The 15 minutes is about as much as you get. So working with finishing crews, making sure that you have a good relationship with them and you can communicate and say, hey, give me about 20-minute fluff time here. Sometimes they'll be able to give it to you, especially during the winter time where concrete's not drying or hardening as fast. You got a little more time. Summertime, it's a little different of an animal there, because concrete does harden quickly. But if you go in, you scan, everything looks good, and you give the thumbs up to the finishers, they'll move into the next section. And you guys just keep repeating this process. So now, scanning for FFFL. This is going to be the make or break scans. If you've done everything, it's going to be the make scan. But if you've skipped steps, like you didn't help the finishing crew out, or the finishing crew had a bad motor, it could be downhill from there. These scans all need to be in fine mode, and with the GTL. The reason I say fine mode is we want as much data on the slab as possible. You want that 50% overlappage. Reasons behind that is, like I said, the more data you put in, it's a tighter, accurate point reading coming out, because it's averaging points in a cluster. And so you get better results that way. Typically, you want to do this as soon as you start seeing the concrete slab get I call it a water look. It's a real polishy look to it. You want to capture the data at this point. And that's the other reason you want the 50% overlappage, is because at this point, there's no one else on the slab except for maybe a finisher, like this guy spraying a curing compound on the slab. And I'll give you a heads up, I've come across this several times. Depending on the cure, sometimes it's like a white liquid chemical that they put on. You can scan that without a problem. If it's watery and they spray it on thick, you're going to have to let that stuff dry. It will give you bad results out of your scan. Take it from me, I've done it. I've been on a project until almost midnight waiting for cure to dry. So these, at this point right now, this is the best time to go in, though, is either right before the curing guy goes in or a little bit after him, about 15 minutes after him, to go in, because no one else is on the slab. At this point, you probably don't even have the saw cut guys there, so you don't have to worry about cutting or working around them, cutting them out of the point clouds, things like that. The other thing is if you come the day after the concrete pour, and guys have walked across this brand new slab, saw cutters have come through and they've done their saw cuts and left dirt pile or little concrete powder hills there. They say they shouldn't, but it happens, unfortunately. You have to work around all these variables. But if you can capture it shortly after the slab is hardened up enough to walk on, it's less work in the office that you have to do. So when talking about a large slab, you want the overlap, kind of like I said here, and treat like where you see the black boxes. These are going to be typically your blockouts for your columns, your anchor bolts. And this is like a large warehouse slab. I usually, between the black boxes, I call those bays. And so I typically would set a scanner up in each bay and scan. Well, that's a lot of scanning you're going to have to do, and be prepared for it. You can speed things up by having fixed backsights set up around the slab where you can just set up anywhere in those bays, shoot those backsights up, and then it'll lock everything in. That's the easiest way to go. If need to be, have one fixed backsight on like a tripod or a prism pole with a prism on it at the other end of the slab, and you have another little prism with you, and you just shoot points and just put a little crow's foot, little pencil mark, an X on the slab, and then just set your instrument up on that every time. But I highly recommend doing this setup anywhere and backsighting into like 3 prisms. It is a lot quicker and easier. So, processing the scan data. We're going to use Rithm to do this. I always recommend Rithm for FFFL values because the reports that come out of it are easy to understand. They give you a clear picture of what's going on. And it tends to work with the with the point clouds very well. On top of that, Rithm just came out with a new release. We're now at Rithm 1.9 that offers some benefits towards FFFL. It helps make sure that you're going to produce a legal report when you're using it. And so when I say a legal report for floor flatness out of the GTL, there are rules to the 1155 guides, and the biggest thing you want to do, and the Rithm software will help make sure, is when you place your sample lines, you have enough sample lines. You have the correct lengths going north and south as you do east and west. So like the example here, the 2 that are right, you notice there's 2 different patterns. We have the parallel and perpendicular on the top, and then what's known as a zigzag on the bottom. These 2 are the right ways to go about, but the 4 on the left or on the right are not. Like I said, you have to have the same length going north and south as you do east and west, and then your zigzag lines need to be 90 degrees from each other or with each other. So that's why these other ones don't work. But like I said, knowing the rules, having good, clean data going in, and making sure you have enough overlappage on your data will only yield to higher FFFL values. And contractors, this is how concrete contractors, that's how they make their money. If they have a slab that does not meet spec, they're out the cost of making it meet spec. So the more we can sit there and show that, hey, if we pre-scan before your finishers get on, the better off we are. If we are constantly working with the finishers, checking them, we're only going to get higher values. So with that being said, anybody have any questions? All right. Well, thank you so much, everybody that attended. If you do come up with any questions, please definitely reach out to your local Topcon representative. We'll always be more than glad to assist you and try to find the answers for you. And with that, thank you so much, and you guys have a good day.